Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma salli wa sallim wa barik ala Sayyidina Muhammad wa ala alihi wa sahbihi wa barik wa sallim. Assalamu alaikum students. This is Hamza Noor, and in this particular video, I'm going to discuss a question from the topic vectors, May June 2021, paper 3, variant 3. Question number is 9. A-level maths 9709, pure maths 3. The question is saying that the quadrilateral ABCD is a trapezium in which AB and DC are parallel. With respect to the origin O, the position vectors of A, B, and C are given by OA is equals to minus I plus 2j plus 3k, and OB is equals to I plus 3j plus k, and OC is equals to 2I plus 2j minus 3k. Given that DC is equals to 3 times of AB, find the position vector of D. So first of all, we are going to use this relationship over here that DC is equals to 3 times of AB. So in order to break this vector DC, what I can write, OC minus OD. I'm just using the subtraction rule. This rule you have studied since you're studying this since O levels and IGCSE mathematics. So OC minus OD is equals to 3 times of, in order to break this vector AB, I can write OB minus OA. All right, so OC minus OD is equals to 3 times of OB minus 3 times of OA. Now you need to find the position vector of D. You need to make OD the subject of the equation over here. You need to make OD the subject of the equation. So OD is basically equals to OC plus 3 times of OA and minus 3 times of OB. So OD is basically equals to OC is 2I plus 2j minus 3k. So 2 minus 3 plus 3 times of OA. So minus 1, 2, 3 minus 3 times of OB. So 1, 3, 1. All right. So OD vector is supposed to be 2, 2 minus 3. And then plus minus 3, 6, 9, and then minus 3, 9, 3. So OD vector is just add up all the x components, y components, and z components respectively. So 2 minus 3 minus 3, this is minus 4. 2 plus 6 minus 9, this is minus 1. And the z component is minus 3 plus 9 and then minus 3. This is positive 3. So OD vector is minus 4, minus 1, 3. You can also write your OD vector in the form of I, j, and k. So OD is equals to minus 4i minus j plus 3k. This working is for 3 marks. Now part B is saying that state a vector equation for the line through A and B. So you need to form an equation of the line AB. So this is in the form of R is equals to A plus lambda times B. So in place of A, I'll take this position vector OA. So R is equals to OA plus lambda times of, the line is going in the direction of AB. Since you have started from the point A, so you are going in the direction of AB. If you have started from the point B, so you will be going in the direction of BA. Okay, so R is equals to OA vector is minus I plus 2j plus 3k. So minus 1, 2, 3 plus lambda times of, you need to actually find the AB vector. So AB vector is equals to OB minus OA. All right. So OB is 1, 3, 1, 1, 3, 1, and OA vector यहाँ पे भी लिखा हुआ है. So minus 1, 2, 3. So this is 2, 1, minus 2. So AB vector is 2, 1, minus 2. So the vector equation of this line is R is equals to 2 lambda minus 1, 2 plus lambda, and 3 minus 2 lambda. This is your vector equation of the line AB. This is for 1 mark. Now in the part C, find the distance between the parallel sides and hence find the area of the trapezium. All right. So first of all, what you know is that AB and DC are the parallel sides of this trapezium. This whole four-sided figure is a trapezium, and you need to know this fact as well, that DC is equals to 3 times of AB. So you need to consider this thing as well. So if I make a sketch of the diagram, so if this is line AB, so DC is basically 3 times of AB. So I'm making DC like this, and this four-sided figure is basically a trapezium. All right. So AB and DC are actually the parallel sides of this trapezium. First of all, we need to find the distance between the parallel sides. That is basically the height of the trapezium. So in order to find the area of the trapezium, half into height into sum of parallel sides, you actually need the height as well. So distance from point A to the line DC. And let's say on this point, on this line DC, there is a point called X. So first of all, we need to find the vector equation for the line DC in the form of R is equals to A plus TB, where R basically refers to the position vector of any point which is lying on the line. So I will first find out OX vector in terms of T, in terms of a parameter. Okay. So in the form of R is equals to A plus TB, as simple as that. So I'm going to find, first of all, I'm going to form a vector equation for the straight line DC. So R is equals to A plus TB. So R is equals to, I'm starting from the point OD. This is my position vector, and T times the direction vector DC. So OD is basically how much? -4, -1, and 3. So -4, -1, 3 plus T times DC. First of all, we need to find the vector DC. So DC is basically equals to OC minus OD. OC minus OD. So OC is 2, 2 minus 3. And OD vector is -4, -1, and +3. So DC vector is 2 plus 4, which is 6, 2 plus 1, which is 3, and -3 minus 3, which is -6. So this is your direction vector DC. So this is basically the vector equation of the straight line DC, in which R is equals to A plus TB. R basically refers to the position vector of any point which is lying on the line. And since we know the fact that we have assumed that a point X is over here, X is basically the foot of the perpendicular from point A to the line DC. So OX is basically equals to this thing. I'll just write it in an expanded form: 6t minus 4, 3t minus 1, and 3 minus 60. All right. So this is your OX vector. Now what you need to find actually the magnitude of AX. So first of all, let's find out the vector AX in terms of T. So AX is basically equals to OX minus OA. So OX is 6t minus 4, 3t minus 1, and 3 minus 60. Now you will take away the OA vector, which you know according to the information of the question: -1, 2, 3, -1, 2, 3. And this is your AX vector in terms of T. 6t minus 4 plus 1, so this is 6t minus 3, 3t minus 3, and 3 minus 3 cancelled out, so you have -6t left. So this is basically the AX vector in terms of T. Now we need to actually find the value of T which is satisfying the condition that AX line is actually perpendicular to the line DC. So what I'm going to do is take this AX vector and the DC vector, I mean the direction vector of the line DC, and I will take out the scalar product, and this scalar product will be kept equal to 0. So AX vector is basically in terms of T, and we will take the direction vector of the line DC, and the scalar product will be kept equal to 0. We will find a certain value of T which is satisfying this condition. All right. And the scalar product is equal to 0 because cos 90 is equal to 0. Angle between the two lines is 90 degrees. So 6t minus 3, 3t minus 3, and minus 60 with the scalar product of the direction vector of the line DC, which is 6, 3, minus 6. 6, 3, minus 6. And this whole thing is equal to 0. Therefore, 6 times 6t minus 3 plus 3 times 3t minus 3 minus 6 times minus 6t, and this whole thing is equal to 0. Therefore, 36t minus 18 plus 90 minus 9 plus 36t, this is equal to 0. So 36t plus 36t plus 9t, 72 plus 9, 81 हो गया. 81t minus 27 is equals to 0. Therefore, 81t is equals to 27. And therefore, t is equals to 27 divided by 81. In its simplest form, t is equals to 1 over 3. This is the value t is equals to 1 over 3, which is satisfying this condition that the line AX is perpendicular to the line DC. Okay. So what do we need to actually find? The magnitude of AX, right? The magnitude of AX is basically the height of the trapezium. So just substitute this value of t, which is 1 over 3, into the vector AX, so that you can find out the vector AX in the form of XYZ components or IJK components. So AX is basically 6t minus 3, 3t minus 3, and minus 60. So 6 times 1 over 3, and then minus 3. 3 times 1 over 3, and then minus 3, and minus 6 times 1 over 3. So AX vector is, just simplify these terms. 6 divided by 3 is 2, 2 minus 3 is minus 1, and this is 1 minus 3, so minus 2. So the last one is minus 2. So the magnitude of AX, which is the height of the trapezium, this is equals to under root of minus 1 squared plus minus 2 squared plus minus 2 squared. थोड़ा zoom in करके लिख रहा हूँ. All right. So the AX magnitude is 1 plus 4 plus 4, which is under root of 9. So AX magnitude is equals to 3 units. So height of this trapezium is 3 units. All right. We know this height. Now we can actually find the magnitude of AB and the magnitude of DC. Now, in order to find the magnitude of AB, very simple. We know the vector AB itself. So the magnitude of AB is supposed to be, AB हमने actually find out कर लिया था when we were finding the equation of the line through A and B. So AB vector is here 2, 1, minus 2. So under root of 2 square plus minus 1 squared plus 2 squared. ऐसे ही था. Sorry, 2, 1 and minus 2. तो उसको लिखें आप इसको प्रॉपर इस तरह. वो अलग बात है, मैग्नीट्यूड सेम ही आएगा, लेकिन प्रॉपर जो तरीका है लिखने का, 2 square plus 1 squared plus minus 2 squared. All right. And then we can actually find out the magnitude of AB. So which is 4 plus 1 plus 4. Again, this is under root 9, which is 3 units. And since we know the fact that DC is 3 times of AB, DC is 3 times of AB, so we can say that the magnitude of DC is equals to 3 times the magnitude of AB. So the magnitude of DC is 3 times 3, which is 9 units. So in order to find the area of the trapezium, half into height into sum of parallel sides. So in this case, the height is basically AX, and one parallel side is AB, and the other one is DC. All right. So here you go. So half into the magnitude of AX was 3 units. AB is also 3 units. DC is 9 units. So 9 plus 3, this is 12. 12 times 3 is 36. 36 divided by 2. 18 units square is basically the area of the trapezium. As simple as that. If you found this video useful, so share this and watch this and give me your feedback. And best of luck for the exam P3. Today is a big day, 2nd November 2021. अल्लाह आप सबको कामयाब करे. अस्सलाम वालेकुम.